Hello, welcome back once again. I know this integral looks almost unsolvable, right? Have you thought about factoring the denominator? X cubed plus x squared plus x plus 1? I think that will be possible, right? Let's first call it I. Then let us factorize the denominator. We have x cubed plus x squared plus x plus 1, which is same as x cubed plus 1, which is the same as 1 cubed, and then plus x squared plus x. Then we use this nice algebraic identity for sum of two cubes, right? So we have that a plus b multiplied by a squared minus ab plus b squared is equal to a cubed plus b cubed. So use that right over here, and this becomes x plus 1, right? Then multiply by x squared minus x plus 1. And then plus, factor out x here, and we're left with x plus 1. Okay, that's nice, right? Okay, so from here now, we can see that x plus 1 is common. So take it out. And then we have x squared minus x plus 1 plus x. And this finally gives us x plus 1 multiplied by x squared plus 1. Oh, this is wonderful, right? Okay. So therefore, our integral I, which is equal to the integral of 1 divided by x cubed plus x squared plus x plus 1 dx, this is going to be equal to the integral of 1 divided by x plus 1 multiplied by x squared plus 1, and then dx. Okay, now, so from here, we're going to decompose this into sums of partial fractions, okay? So how are we going to do that, okay? So we have 1 divided by, we have x plus 1, right? Multiplied by x squared plus 1. So we're going to have a constant divided by the first x plus 1, and then plus, remember the next one is a polynomial with the second degree, so we're going to have b of x plus c, and then divided by x squared plus 1. So whenever you want to solve for the constant a, we're going to let x plus 1 equals 0, and we see x is equal to negative 1, right? And whenever we want to solve for b and c, they are the next constants, then we're going to let the denominator x squared plus 1 equals 0, of which we know that a solution there is x equals I. We actually know we have plus or minus I, but we can just, with one value, we're done, right? Now, if we multiply both sides by this product, then we have at the left hand side 1, which is equal to a multiplied by x squared plus 1, and then plus bx plus c multiplied by x plus 1. Now we need to solve for a, right? Then we're going to let x equals negative 1, just like we said earlier, right? So, you know, with this place, with x negative 1, this turns out to be 0. And we're left with 1 equals a into bracket. So negative 1 squared is 1 plus 1 is 2, right? And we see from here that a is just 1 by 2. We need to solve for b and c. We let x equals I. We know with I, this place turns out to be 0, right? And at the left hand side, we now have 1 equals b times I plus c, then into brackets I plus 1. So we have 1 equals b times I here will give us negative b, because I times I is I squared, which is negative 1. So we have negative b plus bi times this one right over here, that will give us bi. Then this c times I here will give us ci, and then plus c times 1 here, that will give us c. So we group this as negative b plus c, and then plus I into bracket b plus c, right? And at the left hand side here, we can write that as 0i, showing the imaginary part, plus 1 is equal to negative b plus c plus I into bracket b plus c. And we can compare both sides, and we see that b plus c will be equal to 0, while negative b plus c will be equal to 1. And we see that from here b is equal to negative c. You substitute here, we get c plus c is equal to 1. Again, c is equal to 1 by 2 if you solve that equation. And here b will be equal to negative 1 by 2. Therefore, our I will be equal to the integral of a divided by x plus 1, right, plus b of x plus c divided by x squared plus 1, and then dx. Remember, a equals 1 by 2. So therefore, I will be equal to, take the 1 over 2 outside, we have the integral of 1 divided by x plus 1. We can put our dx, then plus b equals negative 1 by 2, right? Okay, sorry for that. So b equals negative 1 by 2. We can take the negative 1 by 2 outside, and we have x divided by x squared plus 1. Remember, we need to split this, right? And c equals 1 by 2. Put dx and the value of c outside, and we're left with 1 by x squared plus 1, and then dx. So here it is easy enough that this is 1 by 2 ln of x plus 1, right? And here negative 1 by 4. If you do that, we're going to have 2x up here, then divided by x squared plus 1 dx. You get the idea? Because 2 divided by 4 will give us 1 over 2. And here plus 1 by 2, the arctan or the inverse tangent of x, and then plus c. But remember that the derivative of the denominator here will give us that numerator. Then we use this nice property that f prime of x, the integral of f prime of x divided by the f of x itself will give us just the natural log of f of x. So use that and we're done. Therefore, we have I equals 1 by 2 ln of x plus 1 minus 1 by 4 ln of x squared plus 1 this will even always be positive, right? So there's no problem with that. What the fuck is wrong with my pen? So here, okay, and here plus 1 by 2 the inverse tangent of x, and then plus c. So this right over here is our solution. Thank you for watching. Please, if you enjoyed the video, kindly subscribe to this channel. Also like, comment, and share.